Welcome back to Cognitive Processes. In this chapter, we're going to talk about thinking and problem solving. So, we all think about things and we all have problems, don't we? Well, cognitive psychologists think about problems in sort of two buckets. One bucket is your well defined set of problems where you have a clear solution, maybe a small set of starting information, a set of rules for solving your problem, and an easy to study um, problem that you could actually look at in the lab. So think about driving from home to work. You probably have a couple of different paths you could take. You have a clear solution getting to work, and you have a couple of rules of what roads you could possibly take and what are the parameters and restrictions of the path. And so that's the kind of problem that's easy to study. But think about most of our problems, or I think a great deal of our problems in life are what we think about as ill-defined problems, difficult to pin down problems. Think about what you're going to do with your life, the career that you're going to have. When you think about those kinds of big problems, the goals are not always clear, and the steps to solve the problem are also not clear. So I think, like as cognitive psychologists, we gravitate to studying the well-defined problems, but I think in psychology in general, we are really oftentimes thinking about those ill-defined problems because that's what is perplexing for us as human beings, and really what draws us to psychology as a discipline. Okay, so thinking more about those well-defined problems, there's a couple of different techniques you can use to solve them. And they fall under these different kinds of techniques called generate and test, means end analysis, working backward, backtracking, and reasoning by analogy. And what you'll see in these different kinds of techniques is that it makes sense if you have a well-defined problem. These may not work as great for ill-defined problems. So what is this first technique of generate and test? So the idea behind this technique is that you would generate all possible solutions and then test them until a proper solution is found. So think of all the cities that you can that begin with the letter C. You would generate all the possible solutions until you get to the city that you're looking for. So kind of an easy technique to use if you have a fairly simple problem. What's the second technique? And that's means end analysis. This involves comparing the goal with the starting point and thinking of various ways of overcoming the distance between the goal and the starting point. And then just choosing the best one. The task is broken down into manageable steps through the creation of sub-goals. So, you know, think about your GPS. You put in Google Maps or some other, map system to get to your endpoint of getting to work. And then you have a couple of different options and you work your way through using means end analysis. This is a good example of that. The third technique is working backward. And if you've ever played the kids' Tower of Hanoi, you kind of know approximately what the Tower of Hanoi problem is. But in neuropsychological testing, what you do is you present three pegs, and then these little rings in varying sizes are stacked on the first peg, and then you tell the patient, client, or the person in the research study to get all the pegs on the last one. And you have to make sure that you do that in the least number of steps. So if you think about the starting point and the end point, the way that this task works well is you might want to work backwards. Do you put the small disc on the second peg or do you put it on the third peg? Thinking about the end point would help you get to the end point, the correct goal with the least number of steps. Backtracking is another technique where you make provisional assumptions about a solution and then keep track of those assumptions and then undo assumptions if necessary. So, maybe you're thinking about a goal of, do you want to take this job offer? maybe you think through, what are my assumptions about this job? Keeping track of these assumptions might make sense. And then, you think through your assumptions list, and then perhaps some of those assumptions are less important or more important to you. And then you might want to undo some of those assumptions. Like maybe the pay is really important, but the location is even more important. You might want to keep track of that information. And, maybe prestige is part of the decision, and then you realize, you know what? I don't really care about prestige at all, so I'm not going to make that part of my decision making, and then you remove that. You can also reason by analogy. This works sometimes too. Like, think about this. Imagine you're presented with a scenario in a research study that, given a human being with an inoperable stomach tumor and rays that destroy organic tissue at sufficient intensity, by what procedure can one free him of this tumor by these rays at the same time avoiding destroying healthy tissue? Okay, so you're presented with this medical scenario and you're like, I don't know, what do I do with this? Well, the solution in this problem is involve sending weak rays of radiation, weak enough so that no individual ray will inflict damage, but you send it from all different angles so that all the rays will converge. So you send rays this way, and then when they all converge in the site of the tumor will get destroyed, but each individual ray is not really destroying tissue. Okay, so if you present that first problem to people, like, don't feel bad if you didn't get it, because only about 10% of research studies participants would get the answer to this question. But if you're given an analogy, sometimes that helps people come to this conclusion more easily. So for example, you might give them the story of a general, and the general is doing this same thing using a fortress. And so when you're doing that, presenting the analogy might help people. So maybe 30% of the people get the tumor problem if they're presented with this. But if you make it really clear that this is related to the tumor problem, then about 70% of people will get the tumor problem. So, sometimes people will learn an analogy and they don't make the crossover and see the connection. But if you make it super explicit, then they usually do. So analogies can be helpful, and we use them all the time. Like, I will use analogies all the time in teaching because I'm trying to get you to see the connections between maybe one thing that is less familiar to you, and trying to make it more familiar by using an analogy. Another thing that we have to think about in problem solving is what blocks us from solving problems. I'm sure you've had this problem in your life. You have this problem and it's perplexing and you just can't get to a solution for it. What are some of the blocks? Well, one of them is just mental set. When you do something over and over again, whether it's a procedure or thinking in a certain way, then when something new might be better, you just don't even think of it. You're kind of blocked from seeing the connection. So in this example, subjects were doing a set of problems. They used a certain mental set to solve the problems. And then when they're presented with a new scenario, they just can't overcome the mental set to solve the problem. So in these sorts of cases, you definitely want to think about, is there something blocking your problem solving? Another block to problem solving is functional fixedness. It's the unwillingness to think of other functions for perhaps like a common object. So like if I give you a scenario like you want to bake muffins and you have no muffin tin, how are you going to do this? A lot of times people they're just blanking, but like there's all kinds of possibilities, right? You could do all kinds of things. So you have to think of things in unique and creative ways. Another block to problem solving is incomplete problem representation. So I'm sure you've had this advice from people, when you have a really difficult problem, they often say things like, well, write down all the things related to the problem. And they're not wrong, right? Like writing down, being like clear about all aspects of the problem can help you solve the problem. If you don't have all that information, if it's somewhat incomplete, it can block you from solving a problem. So imagine that you're presented with a situation where you have 31 dominoes arranged to cover all the remaining squares on a checkerboard. And you try and think through, okay, well, a domino has, these two sides and you're putting it on the checkerboard, will it fit? If you think about, a domino, it will cover every red and blue or every red and black square, so can you get them to cover the board? And the answer is no, because you'll have one odd square. So thinking about all the aspects of the problem can be helpful. So when we do problem solving, cognitive psychologists will often talk about the fact that you think about the problem space. In other words, where's your first state? Where are you coming from? Where are you starting from? And then what's your goal at the end? And can you get to the goal by different ways? And what are all the directions you could go in that would be possible ways of moving in that direction, but will it get you to your goal or not? So think about, what am I going to do with your life? Think about it as a problem space. Okay, where are you today? What's your initial state? What do you want as your goal state? Like, what are the criteria of things? We can all do a bunch of different things, but what would be a satisfying goal for a career? What are the characteristics you're looking for? And then think about all the different pathways career-wise, like maybe I could do, something related to speaking, but maybe I wouldn't be really well suited to do something related to engineering because I don't have the great background. So you can think about the problem space and lay out all the possibilities. And if you lay it out, maybe even like a diagram like this one, it might be easier for you to think through, okay, what are the possible options that would be good solutions? Even the Tower of Hanoi, you could do that, right? You started with all the rings on the first peg and you have to get to the end point, but there may be different ways you could get to the end point, the finish point. If you move the rings in different ways, there could be a shorter path or a longer path to get to that end point. And that would be part of the problem space. So obviously, we're good problem solvers sometimes, but sometimes our emotions really interfere with our ability to make good problems. If you love really thinking about this topic, I would encourage you to take my Psychology of Money class, because I talk a lot about that problem solving and making decisions in the context of money, and emotions tend to interfere a lot of times. So if emotions can be challenging in making good decisions and solving problems, then you might want to use a computer program. And so, a computer program can figure out the knowledge base of what it needs to know, and then it can learn some rules, like if X is true, then Y is true. Those are like inference rules. It might have a search engine, and then it might have an interface for interacting with the user, allowing it to make judgments. And so solving problems could be as simple as, how do I get to work in my car? Or it could be more complex, like how do I solve this person's symptoms? They come in with a bunch of symptoms and we try and treat the problem. More and more we're using artificial intelligence to help us make these very complex problems seem more readily solvable. So how do we find creative solutions? Everybody talks about creativity, and a lot of times it feels like people think that creativity is not something you can study, but of course it is. Like anything else in psychology, sometimes things that seem like they're not a topic you could study, there are ways, right? So one thing that people often talk about that actually doesn't work that great is the idea of incubation or just unconscious processing. In other words, I'll sleep on it, or, I'll just stop thinking about it and the solution will come to me. And the reality is, when you look in research studies, that doesn't really work all that great. It doesn't really have much of a benefit. But you can engage in things that help you with creativity. You can think about directed remembering or channeling your memory in order to think about a past experience or knowledge that meets some criteria. And may lead you to a creative solution. So if you're having trouble with deciding what career path to take, then think about in the past when you also were faced with solutions where there was an unclear answer. How did you get to that answer? What were some of the things that worked back then? Can you use them again? A second relevant cognitive process is noticing. where the problems are, or noticing similarities between one problem and another. This is like going back to this idea of analogies. The more you think about the problem, not every problem is totally unique. Sometimes there's a lot of overlap with other things going on. And so, can you see the connections? Can you notice? Are you being very careful in observing the world and what information is coming to you? And then contrary recognition is the ability to recognize things for what they are, but also as something else. And so, can we engage in that process of looking at where things are the same, where things are different? All of these things are important in helping us be creative. So we often talk about college students and what employers are looking for, and they're looking for creative thinking and critical thinking. So creative thinking and critical thinking are the two things that come up so often. And one of the things that critical thinking, I think there's like a bit of a misconception about critical thinking, because a lot of times people think that, oh, well, critical thinking is just this skill that you have or you don't have. But one of the things that we know from cognitive psychology is that actually you need to know stuff before you can actually critically think about it. A good knowledge base is essential for critical thinking. So a lot of times when we present material to students and ask them to take tests, and they're like, well, I don't need to memorize anything because I just need to critically think about this information. The reality is you can't really critically think about information if you really truly have that information stored in long-term memory, and then you can access it. So knowing stuff is actually super important for critical thinking. You just need to know stuff and not just look it up in Google, but you actually need to know information. So you're making connections and seeing how things are related and different and all that kind of thing. Then you have to have a willingness to raise objections to one's ideas. We often talk about this throughout all of psychology classes. This type of scientist, these scientists might say one thing, another group of scientists say a different thing, and we're trying to reconcile their two lines of research to see what the answer is. Objections to one's ideas is essential to science, but it is also really critical for critical thinking. Seeing both sides. You're right, but this person on the opposite side of the spectrum might also be right. Where is the connection between those two opposing viewpoints? Critical thinking requires construction of examples and counterexamples, going back to the same idea. Opposite ends of the spectrum, not necessarily a bad thing. In fact, it can be a really helpful thing for critical thinking. And then search harder and look longer. A lot of times we come to one answer, and the quickest answer to us, we think, oh, that's the answer. And we don't really critically think. Digging deeper, don't really come to the conclusion that the very first thing that comes to mind might be the correct thing. Like take some time to process information. Think about the example of thinking about your career path. You do not need to pick your career path in 10 minutes. Right? This may be a process that you mull over for years, and that's okay, because if you're engaging in critical thinking, you're really searching deeply and looking long and gathering information, and all of these things together will make you land on a good decision for you. So in review, there are some general strategies to solve problems. We talked about generate and test, means end analysis, working backward, backtracking, and reasoning by analogy. Those techniques are obviously going to work better for more defined problems. Blocks to problem solving, we talked about mental set, functional fixedness, and incomplete problem representations. These are all going to block us from an answer. And then good thinking involves a willingness to question your own ideas and working with a really good base of knowledge. Don't negate the fact that knowing things, learning a lot of information first before you critically think about something is very important for excellent critical thinking. And that's the end of this lecture.